Good afternoon. I think it's time to start. Welcome to the Campus Network session in the Northern 2014 conference. My name is Jari Miettinen and I'm from CSC Finland and I'm working for the FUNET Finnish University and Research Network. As you have noticed from the program, we will have 3 speakers today. And we will cover the areas of, let's say, wired networking, wireless networking, and then green ICT. So our speakers are Ole Fredvend Hansen from Denmark. You could perhaps say hello.
Hello.
And then we have Anders Nilsson from Sweden, Umeå University. And our last speaker is Albert Hankel from SurfNet. So here we are. So we have some 1.5 hours ahead of us, so let's start. So Ole, please, your turn.
Thank you. Hello everyone. I will report to you activities maintained in JR2 T2 and this will be I will talk about network as a service. So how is this relevant to campus network? It is an offering by which you can configure part of your campus network. So let's start. Campus network provisioned by outcomers. Should that be realistic? If you are targeting a foreign domain yourself, that's okay, but letting outsiders do provisioning in your domain, do you think that is possible? Anyone? Okay, I could imagine some resistance from the networking people, but let's draw a parallel. We see 2 servers operated by outsiders. We are used to using the web and also web applications with uploading stuff, creating accounts, and even cloud solutions where you instantiate virtual servers on other people's equipment. So here you could say, yes, it's possible to operate other people's servers as long as it's within a controlled framework. Going back to provisioning network equipment, yes, I think it's realistic if we can build a framework that is trustworthy. Okay, then, why is this needed? When and if you are utilizing special purpose networking, you need to bring the network into place end to end. One moment we'll jump to what is special purpose networking. That's if and when you need something that is not ordinary IP connectivity. That's dedicated bandwidth, low latency guarantees, or separation from the normal network, virtual private networks, and such. The work I'm describing here is targeting exactly user-controlled service of such sort. So let's get back to motivation. So we imagine we have the need for special purpose networking. Then we could see to Xiang services like bandwidth on demand or multi-domain VPN. And those do address the multi-domain aspect. So using such services, we will have a virtual circuit that is from the edge of our campus to the edge of the remote campus. But before you use it, you will need to configure the campus network in your own campus, as well as in the far end. Doing this on the user's demand is what is our goal here. The technology we will use for this is Network as a Service. And what is Network as a Service? It treats all components of the network as resources. Resources can be allocated and configured for specific tasks. And the capabilities of each of the resources, the capabilities that is of interest, can be utilized. Which components of the network are we talking about? That is the links, switches, routers, and also interfaces on the devices. And more than that. Also whole IP networks can be managed in certain situations. The network server, the NAS server, is controlling the components, and that is, I mean, completely down to earth. They are given the access by secure shell and doing this by the netconf protocol, for example. So you hand over the control of the device to the NAS server. And any part of the configuration is managed by the NAS server. Network addresses, routing protocols, access control list, etc. The server handles several manufacturer devices, and finally the NAS server exposes all the functionality by generic interfaces, abstracting from the specific brand. And do we have such NAS servers? There's some commercial products, NCS from TailF, for example. They're not calling it a NAS server themselves, but I would say it is. Then we have the OpenNAS, which is an open source platform for this. OpenNAS is exposing functions through the RESTful API. And if we look to how abstraction could look in OpenNAS, you see in the bottom the physical devices, and then on the top the abstraction. And if you see this, no pointing, no. Okay, but to the rightmost, you see the router, probably the rightmost router. Then it is abstracted 2 times, and the one time with some capabilities, and the other time with just one capability. So it's up to you what in the specific device you want to utilize. If you see to the architecture of OpenNAS, we see in the bottom part it's some common functionality with resource management and queuing that applies to every resource that be plugged in. And then in the middle part, you see some technology proxy and a module that has to address the specific kind of equipment. And that is where OpenNAS is extensible. If you come with a new device, not yet known by OpenNAS, you can write your own plugin here, your own extension. In the top is illustrated that you can attach middleware to the OpenNAS by also doing a little interfacing. So all in all, this is very extensible, and Also, OpenAS developments. There is a new kernel under development, and this will include authentication and permission management. Transaction management and queuing is already there, but will be taken to a new higher level. And all will be exposed through HateOAS API. That's the hypermedia as the engine of application state. So that's the tool we will be using. And then let's go to Network on Demand, which is the application of Network as a Service that we are working on, that I'm involved with. Network on Demand is an attempt to take Network as a Service to a general service. It's a framework for delegating local networking resources to abroad users in a controlled way. It will make it possible to collect resources and form a desired topology, including all addressing, routing, and etc. Provisioning of the resulting net is done on demand, as well as decommissioning of the resources. So this is appealing to dynamic needs, temporary availability of some sort of networking use. So how will this work? Let's have a look at that. We have a NAS server, the nearest one to the user. And as we know, bandwidth on demand is exposing its services through API, and that is what the NAS server is utilizing. So a NAS user of OpenNAS, if granted the necessary rights within bandwidth on demand, can provision a bandwidth on demand circuit. Then looking to the to the local campus network, the user have to provision the networking needs within the campus network. That's illustrated by the red slice of the network here. And finally, we will look to the remote campus. The resource source owner here will assign local resources to the nearby NAS server, the local server which is trusted at that location. And then if the user in question is granted rights, he can provision resources from this server. If you put this together, we see all the provisioning stuff in one picture. And now we draw out the resulting network that this user can utilize and which is enabling his application. Such a network on demand service, what requirements will this have to the NAS server? This will require a local NAS server where resource owner can hand over relevant resources. And that can be done in a number of ways. User identification and delegation to the specific user. It could be done by token valid for the bearer of the token. Also, it could be done as assigning the resource to a resource pool from where reservation can be made for a limited time. The latter ones are the the techniques obtained by bandwidth on demand. So far, I have mostly been focusing on directly delegation to known users, but it's probably good to consider all of these systems to do it. A resource can be, as we have spoken of before, a network link, networking device, or subsets of such devices. So slicing of devices and resources is an important part of this. So we can give out not full control of a router, but only part of it and specific interfaces on this router to a named user. Resources shall be possible to group resources into units, and actions shall be possible to be applied to such groups or units. So in the top here, just stating what we already have spoken about. NAS servers are well-known technology, well-known in projects, at least in our community. Bandwidth on demand is a production service and can be accessed through API. Delegation of rights to resources is not yet there in OpenNAS, and is one of the things that we have to address. So with this, we can outline a vision for network on demand, and that is made by assigning local network as a service servers, by which the local people can have trust. It's more probable than if it's a central resource. And networking and workflow has to be built to enable the end user for handle the network parts needed to the end-to-end network. So this concept of a local NAS server is supposed to rely on a central service instance. That building such a central service would require global catalog and discovery service, and such services would be a huge system. If we look to our drawing from before, again, I've tried to illustrate that the NAS server is within the local environment, and you assign to this local instance. What we are seeing here is work in progress. It is ongoing work in Jira 2, and proof of concept will probably be part of Xiang project next year. So it's just to go ahead and do these things straight out of the main road, as we say in Danish, lige ud af landvejen. So follow the track. But I would like to look to the technology surrounding. And if we take a look at network as a service, there's certain characteristics: abstraction, dynamic infrastructure, elasticity, resource sharing, consolidation, convergence, and resource pooling. Any concepts that come to your mind? To me, it's cloud. So other technologies that is nearby, and I would like to briefly characterize these technologies and relate them to each other. If we look at software-defined networking, I will take this slide. Maybe you have seen this before. It's a common circulated architecture picture. And in the bottom you have the forwarding instances that will be routers or switches. And they are told from the middle thing. It's the SDN controller. They are told how to do the forwarding stuff. So instead of having a router protocol in the router, the SDN controller is deciding on changes within the forwarding machine. In the top you have some kind of application that is interacting with the SDN controller. So the SDN controller can take needs from the application and make changes to the network. If we look for the SDN in a sort of topology map style, in the left you have without SDN. There is, if it is routers, the blue ones, you have routing protocol and some local state and decision on how to make the forwarding route tables. And the routing protocol is of course communicating, or the router is communicating with the other routers through the route protocol. In SDN, all is centralized, all the decisions on how to make changes to routing. You as an end user of networks should not expect to be aware of the SDN functions. That is done behind the scene through the application. Let's go to another emerging technology, that is network functions virtualization. This is made for consumer network delivery, and the consumer to the left is connected through high capacity lines, gigabit capable is assumed here. And network functions virtualization is about consolidating functions centrally, making the installation at the home more lightweight. So if we, well, this drawing is from one of the telcos that made it within a project where they made feasibility study. And as you see, they want to have layer 2 visibility up to some kind of data center or regional processing unit. And here is the points where they want to do the consolidation. And having computation done away from the user is possible if you have a high-speed link downwards to the user. So network functions virtualization is driven by the telcos and defined within ETSI. But you now and then hear of projects within our world regarding NFV. If we take a look back to network as a service, the application will enable provisioning on, turning back to network as a service. As the name itself, it's a cloudish term as a service. And if we look to a well-known architectural drawing here, the computing layers of cloud, where will we find network as a service? I would say it will be a sub-part of the infrastructure as a service. You as a user, again, would probably not see the network as a service. The application that you are using will be the one enabling provisioning on your behalf. So let's try relate the three technologies. There's some common attributes, that's virtualization and programmability. And if we take a brief look on the relation, we have written down some characteristics of each of the technologies. And we could go further and put this into set theory to the right. And then we can start guess what is within the intersections, the different ones. And yeah, well, it's not that easy to point out what is intersections, but there is overlap. It is much debated within our group whether network as a service is a part of software-defined networking or not. But as I see it, network as a service is more practical-oriented. And in OpenNAS, for example, you see now there's developed extensions that can handle SDN controllers. So to summarize these technologies are complementary. I have a conclusion slide here, and I will just recall the agenda here. And then we can say the critical point will be, will anybody allow others to provision within campus network? Yes, I think so, if the framework is good enough. What is network as a service? It's a developing technology and its coexistence with SDN and network functions virtualization. Network on demand is a promising vision, ready to be built and will enable new developments of the network. So, thank you.
Thank you, Ole. I think we have time for a few questions.
Yeah. No. Okay. On demand. Yes, I have a question to your critical point, and I think that is how secure will such a kind of complex network be, which means how well protected against middle attack, which might be the premises for actually getting an answer, positive answer from the university networks.
Yes. Well, how well will be protected? I imagine this can be done fully safe. What will happen in the local NAS server is that someone grants another person to attach, and there be recognized as the one that should be delegated the rights. And for that, you should use some kind of federated login service. But anyhow, the resource owner is the one that opens up and points to who will be let in to attach to this resource. I think it will be doable.
Well, I have one question if nobody else is going to ask. So I think you described us work which is done in the GN3 Plus project. And you mentioned that during GN4 this will be more production-like. So my question is that how could we join this service?
Oh, yes. Yeah, please make contact, and if you want to speak to me, you will find me during the rest of the conference. In the what's called, after this session, I'll be at the Dike booth where you can meet me. I think there will be, it would be very nice to have interested parties joining the effort within Jira 2. So, yes, please.
Thank you. Let's thank our speaker once more again.
Okay, good evening or good afternoon or wherever you are. We're streaming this, so let's keep it global. My name is Anders Nilsson. I work at the University of Umeå, and sometimes when they get fed up with me, they throw me out on international missions. So I work partly for Sunet, and sometimes I work for the Jean community. And the thing I usually talk about is wireless networks. And as we already know by now, there was a session about wireless networks this morning from a nice guy from CERN who had a really good presentation. And hopefully I will see if I can contradict him in any way. So let's move on. So the main topic here is how I view and what my recommendations are for how to build a wireless network and how to run it, design it, and so on. So as every presentation nowadays, you need to have a picture like that. And if I look out to the auditorium, I see something similar. There are not necessarily as many people here wearing shorts and having Apple MacBooks, but roughly the same. And yeah, the current situation, I mean, as I said, looking out there, everyone is using the Wi-Fi pretty much. And just a quick show of hands. How many here have more than 3 Wi-Fi devices on with him or her to this conference? See if we can have someone who has more than 4. Okay, but that's typical situation. You have at least more than 1 device with you. And yeah, if you look historically, in the old days, you were sufficient just to have coverage, and you have a large cell size, and you had your 2.4 gigahertz band, and people were happy that the Wi-Fi worked around the cafeterias, maybe in the big auditoriums for 1 or 2 guys who brought their laptop and pretty much nothing else. So this has changed over the years. So now we have a situation where we have a massive amount of devices out there. There's a high demand and there's a high expectation from the users that it will work all the time. So typically I say, in the old days it was like, oh wow, there's Wi-Fi here, how nice. And now you get the more comments like, what the heck, why is the Wi-Fi not working? And yeah, I mean, there's, even though people are having computers with LAN ports, they tend not to connect them because it's too troublesome to just bring your cable. So even though you're sitting at the office, typically you're connected wireless as well. And it's increasing, and we have a steady growing demand for better capacity, higher speed, so on. And I'm not sure, I guess the people sitting in the way back can't see that, but you can download the slides later on. What we are seeing now with the standards, especially the new upcoming AC standard, is that the time it takes after the standard is introduced until most of the devices being sold or being equipped with AC, the turnover time is much, much faster as compared to what happened on the 11N. So the forecast now is that within the, I would say, 2 coming years, there will be pretty much all the devices will have AC included. Taking that to account, I mean, even though we see the students coming with new devices pretty much every 6 months, there will still be quite a large base of equipment with older legacy devices. Hopefully, we will be able to put an end to the 11G standard as soon as possible. Pretty much all of the universities, at least the majority of them in Sweden, have turned off 11B by now, which is a good thing. So, yeah, this is pretty much what I already said, so I move on. And as always, sometimes I run into the debate that, wait, why do I need Wi-Fi? We have this 4G thing that everyone talking about, or even 4G advanced. What's that about? And yeah, we have 4G at the university. At the moment, we are currently being provided with something like 300 megabits of 4G capacity, divided all over the university, which roughly translates to 1 or 2 of my access points. So I would argue that the capacity we have in the Wi-Fi network is exponentially higher than the one we get from the 4G. Of course, we could do some agreement with 1 or 2 of the operators and install small cells within the building. But then again, do all your devices support 4G? I mean, there's a lot of people right now going around with iPads and other type of devices that basically doesn't have any 4G. So I would argue that 4G is a thing that you can use when you're out of the campus. It's a nice thing to have, definitely, and it's much, much better than 3G. But as you see in this picture, actually this picture was taken from the FIFA World Cup, and you see, I'm a bit problem with the colors here, but if you look at these values around between 16 and 18 o'clock, you see that pretty much much of at least the majority of the traffic during the game was being done via the Wi-Fi network. So they had set up a Wi-Fi network for offloading the 4G traffic, and they were hopefully sending. I don't know actually what game it was, but maybe someone can look into that. So, how to design, what to look for? Okay, coverage. That's been taken care of already. Capacity. We need more capacity to accommodate more users. We need more planning for that. We might run into a situation where we need to have even more carefully planned setups, so-called HD installations. I would not consider this conference necessarily a high-density installation. Typically, when I talk about high-density installations, I talk about locations where you have more than 400, 500 people in that particular room. I've been working back home with the ice hockey arena, which takes 5,500 people. That's definitely high density, because everyone is cramped together in a confined space. So that's definitely something to take care of. Location, even though everyone is being scared about the privacy issue, there are quite a few situations where location is a nice thing to have, keeping track of equipment, doing capacity planning, seeing where people are moving, big data analysis, stuff like that. Actually, back home now, they are thinking about taking out some statistics on the usage of the conference rooms, so they can see how much is being used in that fashion. And you can browse through the OSI layers here. I will actually focus on layer 1 and layer 2 in my presentation, but there are quite a few other stuff that you really need to take care of when building a wireless network. So AC again. So my view on AC is that it's an improvement of the 11N standard. And as you see here, the main advantages are that it's 5 gigahertz only. We are getting rid of this major confusion that it still is something we suffer from, that people are buying 11N equipment and don't understand that their equipment only supports 11N on 2.4 gigahertz. And there's standardized beamforming. Beamforming in 11N was like a standard there, where everyone had their own implementation pretty much. We are doing more efficient transmission. We have the possibility to bond all channels together. So if we use all these features, we are able to go from roughly 150 to 433 megabits per second on a single stream. So do we end up with these fantastic gigabit speeds now? Well, not necessarily. The thing is here that not all of your devices are supporting 3 spatial streams. Typically, if you have a smartphone, you have 1 spatial stream. So you end up with, at the best, 433, and I will get back to why I don't think that will be done either. And you have other issues which will show up in later slides here. Okay, let's put it like this: if you have a device and access point that supports 3 spatial streams, you're living out in the forest, and there's only 1 device being attached, then I reckon that you would be able to at least break the gigabit speed barrier. But that's something that it's more of a technical performance achievement. That's something you won't see in the real world. And getting back to these 80 and even 60 megahertz channel that people are talking about already, which is something that will show up in what they call the wave 2, as was presented this morning. We have the issue that, and let's see if you're able to see this. Yeah, typically you have a lot of channels, but what you're doing is that you're combining them. So if you have 40 megahertz mode, 2 channels put together, you typically have 9 non-overlapping channels to choose from. And if you go to the 80 megahertz mode, you run into 4, and the 160 you have like 2. And people who know the situation with 2.4 know that then you end up in basically the same situation that you have on the 2.4 gigahertz band. You have too few non-overlapping channels, and it's all about spectrum reuse. Not having another access point interfering with your access point channel. That's really, really crucial here. So, well, actually, I could put out also, as I said in the last sentence of the slide here, that ETSI is working on freeing up more MO spectrum. Whoa, MO spectrum. In the US, they have freed up some more channels, so there are more spectrum available, as I think this picture is showing. I'm not sure if this is the actual latest numbers, but there will actually be work being done in the EU to free up more spectrum. But even if even if that happens, I would reckon that maybe you get 4, maybe 6 additional channels, so it's not something sensational. So what I would argue is, as I said, this was all about spectrum use. And this is a horrible picture, but what I'm trying to say here is that if you're running in 20 megahertz mode, you are being able to use that 20 megahertz band more efficient than if you spread up your energy, you divided it up to several channels bonded together. So if you want to use your frequency as much efficient as possible, you really have to go down to 20 megahertz, which is typically what you do in a high-density environment. In a normal campus environment, I would argue that 40 megahertz is a good way to go, which is done here, and 80 megahertz if you have some remote site somewhere. And there was also this talk about multi-user MIMO, which is something we'll be seeing beginning of next year. I've been talking to one of the persons who work at the Wi-Fi Alliance, and when we asked him how well will this work, he kind of laughed at me and said, well, we'll see. The thing is that in order for this to work, and it's a fantastic idea, because most of the devices will not support many spatial streams, so what you do is you take all these spatial streams and divide it up, so you have one spatial stream going to that device, one to that, and one to the third. But the thing is, in order for this to work, you need to have these devices separated spatially enough so they can distinguish between each other. And also, it does set a requirement of better SNR, signal-to-noise ratio. So right now, the discussion is whether it's better to send fast to one device at a time, or to send slow to 4 or several devices at a time. And also you have the issue, if these devices are moving around, if you have 2 persons walking and meeting each other in a corridor, the multi-user MIMO, because they get so close to each other, it won't work. So you have some really interesting things in the future where you're doing some debugging and you're like, okay, we were standing 50 meters apart and it worked great, and then we met each other in the corridor, it stopped working. Yeah. So to summarize, and this is something that was addressed this morning as well, the question is, do you really need more than a 1 gigabit uplink with this new AC standard? And I would argue that the answer is no. Field tests have shown that typically you won't reach above 800 megabits. And please keep in mind, it's still half duplex. You have to think about the fact that typically at least half of the traffic is going in one direction, and the uplink you have from the access point is full duplex. But even so, at the moment, if you want to be future-proof, some companies definitely argue that you should have at least 2 Cat 6A ports to the AP. So if you do a new installation, put up an extra port close to it. So I tried to put up something mythbuster-like in here. I think I've addressed all these things. The only thing is, well, AC will not make you look better, but your APs will, hopefully. Another thing that is making AC much faster is this 256 QM mode. But the thing is, for it to work, you need a really, really good signal-to-noise ratio. So you basically can't be further away than 8 meters from the AP. So So if you want to design for that, you really have to have your APs really, really close. And then you end up as well with the channel planning issue, and then you really, really have to run it in 20 megahertz mode. Importance of good design. And this is something I keep coming back to, because in the end, it doesn't really matter how good you make how good hardware you have. Even though some manufacturers say I'm better than the other one, I would still argue that the best thing you can do is have a good design, good implementation, and also good configuration. And here I have some horror stories I can show you, and others if you like. I have this thing about collecting funny pictures wherever I go. And well, you can read. This is something that is really important to get involved in the early stages and to go all these stages through when you are doing a new design, or even when you're doing a redesign. And as well, one really important thing here is to have an open dialogue with the management or the people who give you this mission to set up this network. So you have the right expectations. I mean, sometimes people come to me and say, well, couldn't we just throw out our wired gigabit net, because I heard now that we can run on AC instead. And I go like, no, you can't. You can't replace a switched full duplex gigabit network to all your computer-aided design systems or whatever you have with AC. And another thing that is important when you have gone through these steps is also to have the right tools. Hopefully you have some tools from the manufacturer of the wireless systems, but you typically need other tools for planning, for surveying, for keeping track of the RF spectrum. Some of the providers of wireless equipment have built-in spectrum analysis and surveying. Sometimes it really makes sense to have stuff like that on your own laptop or some handheld device. If you see me running around, I'm running around with the Fluke tool here. And also keep in mind that it's sometimes not necessarily the wireless network, but it might be the wired network that you connect your APs to that is a problem. And this circle of quality assurance, or whatever you call it, it's true in this line of work as well. So if AC doesn't cut it, is it a new standard coming up soon that will rectify all those problems? Well, they're already talking about this 11AX standard that will maybe replace. We'll see. 2018 is the goal right now. And there are still quite a few. I mean, AC was kind of building on the problems with the N standard, and they already know that there are things that didn't come into place for the AC standard, so they took all this stuff and started working on the AX. And it's not necessarily much faster, but it will hopefully be more efficient, because there's a lot of overhead, a lot of control traffic, a lot of stuff that isn't optimizing the traffic that hopefully will work here. But it's a fun business to be in. If you just wait a few years, there's something else quite new coming out. So let's see. So this is my summarization. To look into the future, there's another standard which I didn't bring up. People are talking about it. I'm not sure if it will fly. It's out there. There's no real implementation. Basically, it's thought to be used as a replacement for all the cabling. So you have something here and you have something here, and you can go between the devices within the room. Maybe eventually it will show up so something you have on on the access points as well. It would work quite nicely if you have classroom environments, because that type of frequency doesn't leave the room. So you can basically have one for each room. Everyone's talking about the Internet of Things. Let's see how many devices we have on your wireless network 5 years from now. We have a lot of issues with this multicast DNS devices, which is essentially the Apple TVs and the and the AirPrint stuff. And another thing that is we're really seeing, at least back home, and I pretty much think that everyone is seeing this now, is we're running out of IPv4 space because we have more and more devices demanding demanding more of the network. So going to IPv6 is really, really important. And Passport phase 2, actually Passport phase 1 is the one taking care of SSIDs. We will eventually end up in a situation where we don't have an SSID. We will have the clients negotiating what network to connect to, and there will be other ways of connecting to the network instead of using these SSIDs. We already paved the way in the EdgeRoam community, so we already have a reserved number in Passport for EdgeRoam, so that's been taken care of. Okay, if I understand Jari right, I'm not necessarily on time, but almost. Okay.
Thank you, Anders. Do you have questions?
Come on, you have something to ask me. Come on.
Yes, I have a question. Run into a problem at large conferences with the mobile devices running around the building and more or less tying up all the access points. Is there a good approach to limit that somehow without interrupting the links too often?
Are you talking about people who have smartphones running
Yeah,
as wireless
exactly.
hotspots?
Yeah.
Or
And running from one room to another, and they are still registered with the previous one.
You're talking about roaming when you move in a building.
Yeah, basically, you're roaming inside.
But that's something that modern wireless networks takes care of automatically. You move from one AP to another. The thing is, there's still this issue with roaming in the sense that clients behave badly, so they tend to stick on the access point it started with, and don't move to the best one, the most optimal.
Yeah.
And this has been taken care of, sort of, that there are new standards that assist the clients in order to do that. There are manufacturers who have different solutions to do that. My take on that one is that typically, yes, there are some roaming assisting standards, like fast transition and stuff like that. But the thing is, when you combine that in the bring your own device environment, the issue here is if you turn on one feature, you cut off some of the clients because they doesn't support that particular feature. So there have been issues where, okay, you can turn on this feature, but if you have an iPhone older than, say, 4S, that feature isn't supported, and those can't get online. So if you run a company, have total control of your device, is fine, but in the bring your own device world, it's still an issue.
Okay.
Yeah.
Thanks.
Going once.
Well, perhaps I ask a question too.
Yeah, sure. Yeah.
1, 2, 1, 2.
Yeah,
It works.
hearing
Right, so it seems we too are asking the questions. Right, so my question is, I'm asking what kind of wish you would like to make.
Oops.
All right.
Wish in order, in the sense of?
In the sense of technical improvement in the field of wireless technologies.
I mean, we already brought up one issue, which is roaming, and another thing that I just briefly touched this passpoint thing. I do think in the future, because this thing with SSIDs has really been crippling wireless infrastructure. I do believe that when this is fully deployed, and as I just said, in your bring your own device environment, we need to have all the devices supporting this passpoint stuff. That's one thing. Another thing that is really, really important is, apart from the roaming stuff, we still have a lot of applications running on wireless devices where you would like to have some sort of quality of service being implemented. And if you look, for instance, if you're running voice over Wi-Fi, and if you don't have a standardized, proven device, and you just say all people with Androids and iPhones can run that device, it won't fly typically, because even if the app tries to convince the operating system to tag and use quality of service, it never really works. So that's another thing. More standardization, better implementation. And hopefully one day all the people who write the drivers for wireless the cards will work. That's more than one thing, I guess.
And that's 3. But thank you, Anders.
But typically, if you get the genie in the bottle, you have 3 wishes.
Okay, thank you. So let's thank Anders once again.
Yep. Sure, no problem. All right, hello everyone. My name is Albert Henkel, and I'm going to talk about the green ICT maturity model that we've developed at SURF. Before I go on to the maturity model, I'd like to start a little bit on green ICT. When I ask people what they consider green ICT, the first things they mention are energy efficiency and data centers. And that's a good place to start, but it's not the only area of green ICT. For example, data centers are only 20% of the total ICT footprint if you take it globally. 60% is end user devices, 20% is the network, and 20% are the data centers. And if you're talking about energy efficiency, you're talking about the energy consumption of your hardware, and that's of course not the only part of the story there as well. You can talk also about how equipment is made and how you recycle equipment. So you should consider the whole life cycle when you're looking at green ICT. But still, it's a good place to start, and this is something that we also started at SURF in the Netherlands. And we did an ICT scan on a number of institutions in the Netherlands, and there we asked, well, what was the energy consumption in the data centers and in the computers that were being used? And we found that the energy consumption was roughly 22% of the total energy consumption of one institution. So there's quite a lot of impact that ICT has there. And we also looked into the data centers and the computer areas. And when we looked at the data centers, we saw that they were too old, too cold, and too empty. And with too old, we mean that there were often servers that were being used for 5 or 6 years or even longer. And you should really look at the energy efficiency of servers and also the increasing capacity that they are delivering over the years. And this is a lot faster than just keeping the old equipment running. Too cold, they were keeping the data centers at like 18 degrees Celsius. And I have heard examples where they've running data centers now at over 30 degrees Celsius, and they have to worry about the people working there instead of the equipment. So there's a lot of things changing there as well. And to empty in, that basically means that they were cooling the entire area instead of focusing it on the specific corridors or specifically to the hotspots in the data center. Looking at computer areas, especially in the shared rooms, the computers were hardly turned off during closing hours, for example, in the evenings and during the weekends. And there was also no power management software installed, so whenever computers weren't used, they were still running full power. And translating this into numbers, it was possible with some low-hanging fruit applications to reduce data centers with 25% energy consumption and computers even over 50%. The problem that we were confronted with quickly is that the ICT departments hardly pay the energy bill, so they don't really feel responsible. Well, maybe they do feel responsible for the energy consumption, but they don't get the benefits if they implement some changes there. Like I said, data centers is one thing, networks is another thing. I think this Green Touch consortium is very interesting, where they strive to be radically more energy efficient in networks. They took the state-of-the-art network in 2010, and they wanted to make that network 1,000 times more energy efficient by 2020. And they've already shown in laboratory environments that especially mobile access networks can really become much more energy efficient. Up to now, I've talked about the footprint of ICT and actually the ICT as part of the problem. And what you see here is that ICT as part of the problem is represented in 2% of the total global footprint. But ICT can also be part of a solution. And this is what is expressed here a little bit, and that's also what the World Wildlife Foundation is saying. Don't focus, well, you could focus on the 2% and make it maybe 1%, but it would be much more interesting to focus on the other 98% and try to reduce the footprint there. And this is a study done by, this is the Smarter 2020 study, and this is going into how you could apply ICT as a solution. And here you see again, at the bottom there's a blue line displaying the ICT footprint, and above is the green areas, what ICT can do to reduce the total global footprint. And these are the major sectors that are part of the global footprint, and you can see here power. This is the appliance of ICT in smart grids, trying to reduce energy consumption there. Intelligent transportation systems, smart buildings, e-commerce, those are all the kinds of applications that you can think of when using ICT as a solution instead of a problem. So this is the question that we were asking also when considering a maturity model is, why are we focusing only on the ICT as a problem, and could we do something to make the potential of the ICT as a solution more visible to organizations? So we started with this idea, and I would like to share a little bit about how the model was created. And the first thing we did was we traveled around the country and visited a number of higher education institutions, and we asked them, what do you think about green ICT? Well, they said, interesting topic, maybe not as high as priority as everyone would like to have it, but it's interesting, but we really don't know what we can do with it where we stand. And they wanted to have some facts and figures, some more knowledge. So we suggested a maturity model, what they thought about it, and we organized a strategic workshop with a number of higher level managers from the higher education and discussed what the benefits of such a maturity model could be. These are the main things that they gave back to us. They said, well, it could give more insight into what green ICT is and what areas for improvement could be within the organization, so to generate some inspiration. Of course, that it could deliver knowledge about where they stand, and they somehow do want to compare themselves to other organizations, other higher education institutions. Mainly to see, not necessarily as a performance benchmark, but really to learn from each other. And that's also what's coming back in the third point, is that such a model could create a shared language to more easily exchange knowledge. And finally, and this is also an important aspect, is that many higher education institutions, at least in the Netherlands, and I guess in your countries as well, are working in some way on sustainability in general on the campus. And the ICT department would like to have some way of reporting to higher management what ICT can do for this sustainability policy issue. So we looked at the maturity model and asked the people at the workshop, so what do you want to measure? And we started with some basic questions, whether they would measure the whole of sustainability on the campus or only ICT. Well, definitely they chose for ICT. Next is whether the model should focus on only the green aspects or also on the other aspects of people, planet, profit. There they also clearly decided to first at least go for the planet aspect. The third one is discussing whether ICT as a problem or ICT as a solution should be addressed in the model, and they said, well, we would like to have both in there, but at least start with the greening of ICT, ICT as a problem, and maybe we can add the ICT as a problem solution issues later on. The focus, and this connects to the one of the bullets on the previous slide, is should be not on performance, so not on I am number one and you are number two rankings, but more on improvement, so more internally focused than externally. And we also asked, well, at what level should we bring this in? And we tried to put a dilemma between policy and practice, but they actually wanted both in the model. So this is what we started off with. We invited a number of green ICT experts from higher education and also outside of the higher education to discuss what such a maturity model should look like. We created this with this group of experts, and then we tested it in one of our higher education institutions. So, coming to the model itself, I'm giving a short description here. Well, the thing we started with is we've already created a simple maturity model, and here it's mentioned as on sourcing, and this is the template that we used also for our maturity model. And the reason why we did this, because it was an easy and inexpensive tool to use, and it was totally geared towards self-assessment, so that institutions could use it without our help. We took the point of view of the ICT department in a larger organization. So, for example, the ICT department in a university, and drafted 3 domains covering the green ICT and organization, ICT itself, and how ICT can be applied in operations in a sustainable manner. And each of these domains is divided in a number of attributes and summing up in 21 total. And I've given an example here on the bottom where an attribute green ICT strategy is described with a short definition, and we've described the level 5 description of maturity. And this basically means that, well, we assume that level 1 is that you don't really do anything about this attribute, and level 5 is the highest achievable. And you have to score yourself based on this scale, so whether you feel you're somewhere in between or whether you're close to number 5 or not. Here are all the attributes that are part of the model, and here you again see that the first domain is focused on more on policy, on strategy. The second, the greening of ICT, is focused on the practical aspects, really trying to get ICT material and energy efficient as your infrastructure. And the final area is using ICT to attain reductions in other areas, such as travel reductions, and this here an easy example is video conferencing, of course. Or space reductions when you want to be more efficient about the way you are using your buildings and your classrooms, etc., etc. we are also working on a fourth domain where we want to apply the ICT as a solution idea towards the greening of primary process of ICT. So in the specific case of higher education institutions, this is using ICT in education and in research to make those processes more sustainable. So what you can see here also is that the first three domains are quite generic, so they can be used by any organization. And this is how we built up this model, is that it can be used by any organization, and that if you want to, you could add a fourth domain for your sector, such as the higher education and research sector, to complete the model. Short summary on how to use the model. Well, it always starts with someone in the organization that, hold up, I can't read the slide here, so I'm just, someone in the organization that wants to use the model. We call this the assessment manager, and this assessment manager, he invites a number of people from his organization with different skill sets, so someone from operations and someone from the policy level, maybe someone from procurement, to compose an assessment team. And then he organizes a kickoff with this team to explain what the model is all about and how it works. Then he sends the maturity model to all the participants, to all the team members. It's a spreadsheet where you can just fill out for each attribute what you think is the maturity level of that attribute for your organization. They send it back to the assessment manager, he summarizes the scores, and then you get an overview of what the maturity for each attribute is. And this is really good input for an evaluation session, and based on a discussion during this evaluation session, you can easily define actions for improvement in an action plan. And then after a period, you can reuse the maturity model to check whether anything has changed. So here I took some scores from the test subject. I apologize for showing the attributes in Dutch, but this was easiest for me to do. But the message is clear. Is that here you have 6 people who filled out the scores for these domains, and what you can see is that we've highlighted those scores that were 2 steps away from another score. So there are 2 attributes here that are where 2 people at least are disagreeing on what the maturity level is on a significant basis. And this is really good input for discussion. Another way of looking at this is, well, what are attributes are scoring very low, what attributes are scoring high, and should we do something about those as well. Here's another way to represent scores in a domain. This is just some sample results, and here you can see the same effects where if the blue line and the green line are far apart, then there's really a disagreement within the group on the maturity of this attribute, and this is always good input for discussions, and you can also easily see which attributes score low and which high, and whether you want to do about it. What I do want to stress is that the scores themselves are not that important. It's all about the discussion, because most people fill out this in a subjective manner, and it's also, even if it's reasonably objective, it's really hard to compare it to another organization because of the difference in context and different people. But yeah, it's really good input for the discussion, and that's also what the model is all about. Another thing we did with the maturity model is that we created this maturity model with a small group of experts, but we wanted to know what other people thought about the model. So we set up an online survey, and in which we basically asked, what do you think of the quality of the model? We didn't ask them to use the model, but take a look at the model and say give feedback on all the attributes. And we asked about whether they thought the attributes were relevant, whether they were well defined, whether the description was understandable and not ambiguous, whether they were missing something in the domains. And we had, unfortunately, I think, a small group of people who responded, but still some nice input came out of it. And this is a graph which shows one of the aspects, the relevancy. And if you take a look at the bars, you see that we made a cutoff point at 3, and everything above 3 we considered to be relevant, and everything below not relevant. And we were very happy to see that only 2 attributes were not considered relevant. So we basically created a model that was close to what people expected. And for those 2 that fell off, we can also quite well explain why they were not relevant. For example, the information management was a little bit too far, because this was asking people to think about really digital ways. So what do you do with your data, and do you store it on many devices or not? And this was really too far ahead, I guess. And the other one is other reductions with ICT, and this is just a too general category. So it was basically a catch-all, because we wanted to have a complete domain there, but this didn't really connect to the people who evaluated the model. I also talked about well-definedness, and we also got good feedback on that. Most descriptions need some small revisions to get out some of the ambiguity, and some need more work, so that was good as well. And what we are doing now is we're translating the results from the survey into the model to improve it and release a version 1.1. And also what we want to do is we want to continue to improve the quality of the model, and we also want to ground this not only in practice but also in science. Like I said, we only have a level 5 description, and we want to make it more complete. This can make it more complex to use the model, but we are thinking of offering both only level 5 and the complete model with all the levels described. The 4th domain, we definitely want to add that for the higher education and research institutes, so that they have a complete maturity model to work with. But more importantly is that we really want to test if the model is used and what the impact of the model is. So what we are doing is we are finding a number of organizations, higher education institutions, who are willing to let us follow them in their use of the models, and they are starting with the use of a model, drafting an action plan, and we want to come back after a year or so and use the model again and see if anything has changed. So just to sum it up, we think that the Green ICT maturity model is an easy-to-use, inexpensive self-assessment tool that can be used by any organization basically, and gives quick results. It is made from the point of view of the ICT department, which is of a larger organization, and I think this is quite unique in the landscape of green ICT models and frameworks. It's focused on facilitating good discussion instead of performance. It can be reused to measure internal progress. Like I said, if you come back afterwards, after a certain point of time, you can compare the scores of the second time with the first time. And we really want to ground this in a scientific way as well. But we don't want to make it too rigorous to scare off the practitioners. And best of all, I think, is that it's free to use for any organization. It's available under a Creative Commons license, and anyone can download it here at this address in English and in Dutch if you like it. So that's what I want to share with you. Thank you. And if you have any questions, let me know.
Does anyone have any questions, please? Well, perhaps I can try to start. So you have made this maturity model. So do you have some other green IT activities at SurfNet?
Yeah. Well, we are part of the Xi'an Green Team, and in the Xi'an Green Team we have developed an online audit tool to create a greenhouse gas footprint report for NRENs who want to use it. So all NRENs could use this tool to create a greenhouse gas footprint report. We also, yes. What you were saying, e-waste or environmental policy? E-waste policy, yes. Well, this is my colleague there is sitting. He created an excellent e-waste policy for SurfNet, and this can be easily reused by any other NREN or any other organization, actually. So we are trying to actively promote it not only in our community but also towards the Dutch higher education institutions. It's available in English, or will be. I think it's available in English. Yeah. So if you want to know more about that, you can contact me or Michel and we can share that as well. We're doing a lot of things. We're organizing a Green ICT symposium every year for our Dutch constituency. So about 150 people come visit there and talk about Green ICT and Dutch higher education.
Well, there seems to be no more questions, so let's thank Albert once again. Thank you.
Thank you.
Right, so this third presentation concludes this Campus Network session. And before I let you leave for the coffee, there's small practical things for you. It's about the gala dinner tonight, so it will be at 7:30 at the Uppsala Castle. So please remember that. And there's a bus transportation available for those who registered yesterday, and they leave 7:10 from the hotels, Clarion and Scandic, and 7:20 from the venue. So if you want to use the bus, please be there at that time. But thank you very much for your attention. Let's have some coffee. Thank you.